This week, I've continued working on my CI system. I'm still trying to figure out how all the pieces should fit together and trying to find the basic architecture of the whole system. I've used RL Meta a lot and written a lot of grammars to handle parsing and tree transformations. In this video, I want to give you an update on what I'm working on right now. So, let's have a look. So, the RLCI repo now looks like this. So, it has been structured into the RLCI folder, the RL Meta folder, and the job control samples. So, the idea is that RL Meta is kind of a project in itself. The RLCI is a project in itself, and these are just some examples. And furthermore, the RLCI has been split into a tool directory. So this is a tool that can parse the pipeline syntax and also run stages and interact with RLCI server, perhaps in the future as well. So in the future, there will probably be another component here, which is the web user interface and maybe a server mechanism as well. But for now, I'm focusing on this tool. So more specifically, I'm still trying to flesh out the input and output of stages. So let's see, did I have something in timeline? Yeah, so here, for example, here is a stage. It will take a commit argument as input, and then it will create forward that as an output argument, and then it will also output let's say a doc variable, and the result is the output of this command. So just trying to flesh out how to write stages and how to make it execute. So now I am currently trying to get a specific command to work. So let me show you how this tool works. So there is a make script here that will compile the tool. So now we have a tool which we can run. And it accepts a few arguments. So the first one that I want to show is called, let's see if I can remember. Well, I can. So let's open up the parser here, the CLI parser. So we can say get stage definition. It's the command. And it takes a pipeline. So let's use the timeline pipeline as an example, and it takes an ID. So this is just a sequential number of the stage. So if we're interested in this one, it will probably have ID 1 because this is the first stage and it has ID 0. So let's type 1 here. So when we run that, we get some kind of stage definition. At the moment, this is a string. So I was attempting to compile a stage definition to Python code before, but I think I've changed approach now. So now I would like to return an AST here, which will then be processed by another command, which is this run command. So the idea is that we do something like this, and then we can pipe it to the tool again, and with the run command, and then we can pass arguments like commit is something like that. So what this currently does is that command run is invoked when we execute this run command, and it gets a set of arguments, and it reads something from standard in, and for now it just prints it. So it prints what it receives on standard in, which is this, and then it also prints the arguments that were parsed from the command line. So this is now what I would like to work on and make this command actually do something useful. So what we would like to happen is that it should actually execute hgclone and save a commit as an outward argument and all this stuff. So first thing I want to do is just make sure that this the input should not be compiled Python code. It should just be like an AST instead. So let's see where that is done. So stage in, let's see stage. Okay, so a stage has maybe a name and ys, and then it just has a bunch of body statements. Stage body. Okay, so that's the parser, and then the 2DAG will probably convert that to, yeah, here we go, here is the Python code. So I think, let's see here, stage props, stage code. Okay, so it returns an ID. Let's see, I think stage name, stage, I think these ones I just want to pass along. So what happens? Stage name. How are these used? Stage props. It's just used for the name. Yeah, okay. So stage name. This one will just be as returned as is, stage sh. Let's see. So something like that. Same for stage out. Oops. Just return as is. How about that? What happens now? Let's see. We need to do this as well. Okay, so let's see, what did we get? Oh yeah, and we need to make the new tool as well. There we go. So now we can see that a lot of things are gone here. Yeah, that's good. Okay, so stage. Here is where we this node. So what should we put here? We should put stage code, perhaps. Stage. So let's do stage code, and this do add stage code. This. Okay. How about that? Okay, so now we're getting somewhere. Okay, so instead let's see, footer in the, yeah, so let's do a pprint. Let's see what we get. Pprint is not defined. Oops. Yeah, so okay, so this is looking like something. So okay, we have, this is like an AST for this stage body. So what do we have? First we have stage sh bound to no name, and then we have a string which is built from characters and then an input argument commit. Then we have a stage out, store it in the commit variable, and the result is this string which reads the input argument commit. So this is basically just forwarding that input argument to be an output argument as well. And then we have the stage doc and so on, a stage out. Yeah, so at this point, so what we have done here in this command is that this first part here generates a stage body as an AST and formats it as JSON. And then we pass that to the run command. And the run command will start by parsing the JSON passed on stdin. And then we can write another grammar to process this AST and actually do all these commands and feed back like a JSON stream. That's my idea. So let's see if I wrote it here. Yeah, so when we run the tool, it will stream JSON objects representing what it does. So like if something is written to standard out, it receives something like this and standard error, and then finally a result which might be an exit code or something like that. So that's the idea how like a stage definition stored in a pipeline can be passed to the tool, which will then execute that stage body and return like a log and output. So perhaps this tool will run on a worker node, and the pipe here is how the server might talk to the worker node. So for example, if we can use SSH, we can do something, the server can do something like this. So we can do echo stage AST and then SSH worker and then run the tools and run, and then yeah, that's how I imagine this will work in the future. That was a glimpse into what I'm working on the CI system right now, and perhaps you'll see more about it in upcoming videos. But until next time, bye.